and there's a query API that's really nice and really flexible to get at lists of your data, slices of your data. That's what Perstore is all about. So at the lowest level, actually, these stores, you don't even have to use Perstore. These stores can be shared across different other JavaScript frameworks. So there's a lot of people working on persistence in JavaScript. Especially there's like Node persistence. I think it was Tim Caswell is doing that. There's a bunch of things going on with Node. There's some stuff going on all over the place, stuff that uses the JDBC to talk to SQL. It would be great if we could get together and actually, at the very lowest level, just have an API that we can all reuse the same code to talk to all these different NoSQL databases. And so that's pretty much what this API is about. I'd show you some examples that demonstrate this. But if anybody's familiar with the W3C IndexedDB API, it's that. It's just that. There's get, and that takes an ID, and it gives you your data. There's put. You give it an object and some directives, and it puts it in its store. There's delete, same thing. You get the idea. So the way Perstore works, there's the model's constructed with three pieces, three things that you need to create a model. You require the store, you instantiate it, then you have var model equals. If this was a whiteboard, that would work out really well. But var my model equals, and then you just give it three things. You give it an ID, you give it a schema, which is just a JavaScript object. It's not like XML schema. It's just JSON schema. It's really simple. The empty brackets, like empty object, is a valid schema that means schema free. It means do whatever you want. There's no constraints. And then you give it the store. And so those three things now allow you to essentially have a backend storage for whatever backend storage you want for a given collection. Like some models, just like in MVC, they're like a class. There's nothing. It's not specifically a class. There's no. It doesn't do any magic with. It doesn't require any. Like you to choose a particular class in prototypal inheritance structure, but it's like a class. I mean, it's a place where all of the like things get persisted, and you can talk to that model and say, give me all of it, and then for each over it. For instance, if you're not over HTTP, that's a really helpful thing to do. Or you can just ask for a very specific query, a very specific bit of a model, which is it returns a collection. It actually streams that all the way back through the process, and it returns. If by default, it's going to return application JavaScript if you're over HTTP. So I had a whole progression of slides I was going to use here. And we did some artwork with some leaves. It was really pretty. I'll show you guys later. So that's Perstore. Perstore is all about just storing a very specific type of data that's defined by a model in any database you want. We don't have all of the stores yet. We have many of the stores. There's a Mongo store. There's I'm almost done with a Couch store. If anybody, are you guys Node users? Felix, have anybody seen Node Dirty? So I was, okay, sweet. So I was trying to map that as a store, and then I realized that, wait a minute, we have this thing called a memory store that it just stores everything in memory, but it gives you the same interface to get to data. And so I just wrapped that in so stores compose really well because it has this common API. It just exposes a set of functions. Like that's all it returns. It's an object with a set of functions. And so I just wrap that, and you can override any given like all of the different behaviors that you might need to actually make this memory store to write it out, with new lines separating every, JSON objects. And now you have it. Essentially, you have no dirty, except probably not quite as fast, but definitely more flexible. So you have, you're able to use this common query API that I was going to demonstrate. This is awful. Let me see if I can't bring this up.
Can you describe the query API?
Yes. Okay. So the query API. This is actually the coolest part of. I think the most effective thing that Perstore provides is this notion of the queries themselves they look an awful lot like your standard query strings. And Chris Zipe, when he called it resource query, I think he's going to spec it and actually, IETF it or something. But what it does, fundamentally, it has two primary terms that you can use. So a query would look like over HTTP. A query would look like question mark, foo equals bar. So that would be a comparison query, and that would look like a standard query string. You can do greater than, less than, greater than equals, all of that good stuff. And that's one term. And then there's another, that's a comparison type term. There's another term, there's another type of term called a call, which is, to do sorts, for instance, the standard way is to just say, and sort, open paren, and then you can put the actual sorts as arguments in these parentheses. Close that, and then once you close the parens, you have this thing that parses down as a call. So it's one term in this list of terms. That's your query string. And the parsed object is actually really easy to work with, so it allows you to do some fun stuff to like manipulate queries that come in. So there's this, like at your model, for instance, or you might want to actually override a particular behavior, like it's a blog store. I might have had a whole example that was a blog store, and so you might want to tack on a published thing. Like you might want to say, okay, this is a timestamp, this is the author. You would override the put to do that. It's just like aspect-oriented programming, kind of like a rounded vice, or in Python it would be decorators. It's like you can meta program the store functions that actually that you expose. You can wrap them and do new things. Let's see what else. So, but the query would look kind of, there's different terms, and then they're combined with a logic operator. So either an ampersand or a bar, which is or, and you can have groups. What comes out of that, what gets parsed and what you get to use is just a list of these things, these different terms, and you can use. So I was saying you can actually use it for effective things like. So I wrote an adaptive indexing store that you can take. Say you have a SQL store. Every query that comes in, I can inspect that and say, oh, what fields are you using? And then if it's a field that hasn't been indexed, I can tell the SQL database to create the index. So kind of like how in Perstore 1.0, that's what JSDB did. So in 2.0, I can actually do that with SQL, which makes it kind of fun. Okay, so there's this other notion of the object of facets, that those actually wrap the model. Facets are, they come from OCAP. They are they're a security mechanism. They expose this view of the model, like of the objects that exist in your database. You can see just a bit of it. You get a certain set of capabilities. So a read-only facet would eliminate put and delete, and you would just have a get that you would be able to, you'd just be able to get and query the object. But they also have some other uses, some interesting benefits. So that's the general idea of Perstore. It's on GitHub, Chris Zipe /Perstore. It's incredibly simple. Now that I don't have slides, I'll obviously get the slides online, and to actually instantiate a store, and to use this code, it takes no effort. It's really 10 lines of code, and then all of a sudden you've got a working API to do effectively what Node Dirty does. Except you can, underneath the hood, you can swap that out for Mongo, you can swap that out for SQL even, but then you have to define your schema, obviously, because SQL is not going to do a very good job storing just any arbitrary data. But once you do that, there's now you're completely no longer tied to a specific database. NoSQL or SQL, it doesn't matter. Okay, so ignoring Perstore, there's this thing on top of it that's called Pintura. That's where the HTTP side of things comes in, and that's the most interesting thing to me, because I'm not necessarily, when I'm interacting with my data, I'm usually doing it over HTTP. And so Pintura is just, effectively, its documentation might as well be RFC 2616. It's HTTP, the good parts was what the slide said. But so it does some of the stuff from HTTP that you would typically, most people just ignore. So it uses HTTP, like all these like edge things in HTTP in a really effective way. So content negotiation, turns out that's really useful. Like if you do it right, like if you actually have a means by which to do it, it solves certain problems that I didn't know were there really. Because I'm more interested in just getting JSON out of my database or JavaScript actually, because then you can have functions and you can share them with the client, and that's kind of nice. So I didn't mention that feature, but there's just simply no way to turn a JSON database, to turn the JSON coming out of your database into an Atom feed. You can't do that on the client. It's not really going to work. So it's helpful to have a way to tell the server, hey, I want this thing as application/Atom plus XML. Can you do that for me? That's what content negotiation is, and it works out really well. So a lot of the time, you have to set a header to do that. You say accept application/Atom plus XML. Well, you can't always, you obviously can't do that. If only the browsers were a little smarter, like when you clicked on that stupid little feed button, it actually sent the right accept header. I don't think most browsers do that. It would be nice if they did. So instead of actually, since the client can't set the accept header, the browser's not doing it properly, we can set the accept header in the query string just using a simple little syntax and some JSGI middleware that interprets and tears down all, like you can pass any header you want in the query string if you prefix it with HTTP dash, and it'll just tear that down into a header, and then it'll look exactly like, it'll run through the rest of your application through the middleware stack, looking exactly like the header was set, as an actual HTTP header. So content negotiation can go both ways too. So it's not just for getting data out. It's also really interesting, like for putting data back in, you don't have to serialize everything into JSON. Especially if you're not using like the thin server approach where it's just JSON going back and forth over the wire, then it's really cool. Like if you say you have CSV, like this does happen. It happens to me actually. I work in the enterprise world. CSV, very common. I don't know why. They dump their data out of CSV. It's got no type. It's got nothing. But a lot of the time, that's what you're dealing with. So CSV actually is not that bad of a representation if you have a schema that says, hey, this is a date. Hey, this is this is an integer. So when you define these models and you define your schemas, you don't have to, but you can define a schema, and then you can include this representation that's text CSV, and so someone can actually put back in the interfaces, like I said, I was describing the Perstore interface, the Pintura interface, just as simple. All of those methods map to HTTP. So put and then some object does your put, but you can put some object that's a CSV file and say content type, text CSV, and Perstore will, because the CSV is actually relatively easy to do, so we can have a generic interface that we can have a generic module that does this. So you require that module to turn it on, and then it'll rip down that data into JSON and put it into your database. So it doesn't matter if your database is SQL, if your database is Mongo. Like it'll just put it wherever the data store is. That's not that useful, but it can be useful, like for Atom Pub. You can support any of these models, and what the really cool thing is you can do it in a very generic way. You don't have to choose. You don't have to, every time you write as you're writing your models, you don't, for instance, to support Atom, or to support HTML, for instance, because we can do HAtom. If we can do Atom, we can do HAtom. To support that, you don't have to think too much about how it should look, how your actual model should look. But if you want to override the behavior, you can define a little, there's a little interface that lets you define a get title property. You can define a get content property, a get summary property. And these are just functions that if they exist, the serializer, which you can also override, it'll use those functions to actually make your representation for that specific model a little nicer. So what was going to be next on the slides? One of the nicer things, I didn't really get into the details, but so Pintura, like the way it's built, it's a pure JSGI application. And what that means is all it is this stack of middleware. And I have this interesting slide that's like a log that has the different layers, but it's 14 different layers of middleware, most of which are reusable. They're not specific to Pintura at all. So like I was describing the HTTP headers thing where you can just take any header and it'll pull it out of the query string and put it into the actual header of the request object. So that's pure, Pintura's pure application that way. That's just one little middleware that it uses, and it stacks all of these on top of each other. I should probably define JSGI a little bit better. So it's a web gateway interface. If anybody's used WSGI or Rack, same general idea. We kind of, I guess, deviated quite a little bit to be a little more like HTTP, because CGI, it has some problems. It's got some significant problems. So we papered over a lot of those, and I think it actually came out really nice. Like I think we're still trying to figure out how to finalize it. It still depends on having a few more things in CommonJS. But Pintura is kind of a candidate of it's one of the first applications, I guess, full stack applications that runs across all these different engines and all these different platforms. So it's kind of the first experiment in that sense. I mean, there was Jack, obviously, that is a narwhal application that is kind of the JSGI implement, or kind of default implementation. But
it's a port of Rack, basically.
Yeah, it's a port of Rack. It's this guy, and it's really nice. But so Pintura actually depends on Jack and uses quite a bit of Jack's functionality. So there's just the point I was going to get across was there's just a lot of these pieces you can pull out and use on your own. So, but there's a lot of really cool stuff. So the bottom line, I guess, is it's not that hard to get started with. There's a build that Chris has set up that I should also say, I don't think I said this. It's a Dojo Foundation project written by Chris Sipe. I just kind of like hack on it. I get to do it for work. It's awesome. Like, I highly recommend being able to like hack on server-side JavaScript for your day job, because your life will be a lot easier if you can figure out. Like, I work for a .NET shop, but I get to hack on server-side JavaScript, so I'm a much happier person because of it. But so it's really easy to hack on. I mean, you can crack open any of the modules and you can just start using them. All right, so yeah, you crack open something in Pintura, something in Perstore, something from a depending library, and you can just start changing stuff. It's amazing how it'll just work. There's no build step. I mean, you guys know this, obviously. It's JavaScript, it's interpreted.
So is the interface for Perstore, is that all just RESTful as well? Or
Yeah, so okay, I was supposed to try, I was trying to get that point across, but I guess I confused it somewhere. So Perstore is, it's not necessarily the HTTP part, it's just you would use it from your code. Now, it would be a package you require, but Pintura is this other package. So this is a big branding problem, I think, with the project. There's just these three notions. There's Persevere, which now, 2.0, consists of Pintura and Perstore. So this Perstore thing is just that library that you would require. Pintura requires it and maps HTTP to all the calls. So yes, and it's RESTful to like an insane degree. Like, a lot of people would say, REST is just like, it doesn't really mean anything. Especially now, like, spent so much time working with it. Like, it's amazing how well defined it really is. And like, I mean, obviously there's certain pillars that you try to ascribe to. It's not just the uniform interface. Obviously, like things like content negotiation, things like just using, for instance, content ranges. Why don't we use more of that? Like, we should really do that more. They allow you to take like a resource and have all these different dimensions on it. Now, so Pintura uses the items type, the items content range. That obviously Dojo uses, because again, Chris Sipe's a Dojo committer, so I think they originally kind of created this items range that's representative of a slice of a given query. And so if your store is just a big table, a big list of objects, well then you can look at that store and slice that up any way you want using this simple syntax that's defined in HTTP really well. I mean, it's only defined for the bytes. there's something called a bytes range that's well spec'd in HTTP, but then it just says, yeah, you can use this for other stuff too. In any event, check it out. There's a lot, like, there's so much left to do, but there's already so much you can steal. Like, like there's so much, it already works like really well.